This is a side experiment to the Vesky project, to the main Vesky project, but it's a real nice opportunity and one of those unexpected things that come out of international exchanges like these. So the equivalent to the pear field laboratory is the stone fruit field laboratory where we're in. So there's peaches, nectarines, and plums in this block. And in particular, this variety, Angelino, is very famous worldwide. It's grown in many countries, including Italy. And Mark is running a set of studies here, again, irrigation studies and others. But in this particular end of the orchard, irrigation is standard. There are no irrigation treatments applied here. So this is a good place for us to study a very basic aspect of plum physiology. The question is, how do the fruit grow? Their physics of their growth. How much water and how much sugar are they able to import and retain, which is actually how they grow. For different fruit species, we already know that there are different mechanisms for this. Plums has not been reported until now. So this was a very good chance for us to have a go at elucidating the physiology of phloem unloading and xylem contribution to fruit growth. So this is stone fruit. Stone fruits grow by an early stage of rapid growth, mostly by cell division and some cell expansion. Then they appear to not grow much during the time when the seed teguments lignify, become woody, and then they resume growth in the second burst of fast growth, which is the cell expansion period. For this particular variety, this last stage of growth lasts several weeks, more than 2.5 months. And that's where we are right now. We're nearing harvest, but it will not be until
another 2-3 weeks.
Another 2 or 3 weeks.
Yep.
So this is a good time to come out and spend about 10 days in the orchard trying to elucidate this mechanism. The measures of water potentials that we've just executed allow us to have an idea of how much work is necessary for water to go from the soil to the leaves exposed to sunlight and to the fruit. We also measured the stem water potentials, which gives us a much more uniform, if you would, better average reading of the average work the tree is doing to extract water from the ground. With these three components, we will be able to determine the pressure gradients between the stem and the leaves and the stem and the fruit. Water in the xylem will flow preferentially across the largest of these gradients. These gradients may change during the day. Actually, they do change between nighttime, solar noon, late afternoon. So we've been doing the exercise you've just seen 6 o'clock this morning, but also 11 o'clock and 1 o'clock and 3 o'clock p.m. yesterday. So we have 5 data points that cover 24 hours. This is to allow us to see how those gradients change during the day. When we do that, we'll know where water would preferentially go. And then, using the fruit gauges again, but with a different approach, we'll be able to partition growth of the fruit in its 3 basic components. Growth driven by the phloem inflows into the fruit, so this would be sap containing carbohydrates. growth driven by the xylem flow into the fruit. This would be mostly water from the roots and the ground, and potentially water losses through the skin driven by the vapor pressure deficit. So it gets warm during the afternoon, it gets dry on a typical day in the afternoon. That creates the force to drive transpiration out of the fruit. To achieve the partitioning of growth into these three components, we are using the fruit gauges following a method that was proposed many years ago, more than almost 30 years ago now, in the 1990s, by Sandy Lang, a researcher from New Zealand. This method is normally known as the subtraction method, because what we do is right now the fruit gauges are measuring fruits that are intact. They are growing as they would because they are in their normal condition. Tomorrow afternoon, if all goes to plan, I will come out and remove the bark above and below each of these fruits. Not all of them, we'll keep some for controls, but most of them I will remove the bark above and below. By removing the bark, I will remove the phloem connectivity to the fruit. And that will mean that afterwards, any growth that we will measure will be the intact minus the phloem component. So we will have subtracted the phloem component. After another couple of days, I will come out and detach the fruit completely from the tree. That will sever the xylem connectivity to the fruit and will only allow transpiratory losses to be the driver, the last driver of growth. So by subtracting one connection at a time, we can partition the three components. And then we'll sit down and sort things out. By putting together the picture from all these different bits of information, plus the seasonal growth curve that Mark has produced by taking weekly measurements of fruit diameters, fruit weights, dry weights of some destructive samples, we'll be able to build a picture that should tell us how does sugar, the important component for quality, and water, the other important component for fruit size and yield, get into the fruit. The outcomes of this work can be many. Certainly it's fairly fundamental physiology that we're after right now, and it will need to be confirmed with other studies, hopefully in Italy. So we have the same variety, but the environments are different, so it will make sense to try it in Italy and see how they compare. If they do stack up against each other, then we would have some fairly strong physiological basis to develop growth models that would find application at a later stage in irrigation management systems, where we might be able to irrigate following more closely the quality and size evolution of the fruit. Right now we don't have this information, so we are using the best approach available at the moment, which is to replenish water losses due to evapotranspiration. We hope to find a few places during a day where we can perhaps give a little less water at some time and then give a little bit more water at another hour of the day. So again, the effort is to go from a longer time step to drive irrigation, like a daily water loss, to a shorter time step, like hourly needs of the tree. But that will take a while to develop.